The small world phenomenon. After introducing many definitions and terms, this video introduces you to the small world phenomenon as an example of network theories. You don't need to understand all the mathematics behind this theory, but it's useful that you can briefly explain what is the small world and the research behind it. I bet you have said the phrase, "It's a small world," or thought of it when you are surprised that people in different places are somehow connected. For instance, person A says, "It turns out my professor's daughter plays volleyball with my cousin." Then person B comments, "It's a small world." The small world phenomenon may be the most important and famous line of research in network science. It discovered the principle that we are all linked by short chains of acquaintances. In the 1960s, Stanley Milgram designed a smart experiment to quantify the connection links. Basically, he randomly selected individuals from two cities in Nebraska and Kansas and asked them to try to send a postcard to a person in Boston. The chances that these people personally knew the target person in Boston are extremely low, so they were asked to send the postcard to someone that they think he or she may know the target person in Boston. The same procedure then applies to the next person receiving the postcard. The research team managed to track all the names and stamps on the postcard. Eventually, less than 30% of the chains succeeded in reaching the target person in Boston. The picture shows one example of a successful chain of sending the postcard from the west to the east. Using data from these chains, Milgram calculated the average path length between two people in the US, and he found that the number fell around 5.5 or 6. The famous phrase 6 degrees of separation thus comes from this study. Since then, a number of network models have been proposed to study the problem analytically. Today, we know that networks with small world properties need to have high local clustering and low average path length. Clustering captures local density, meaning redundancy in connections. For instance, my two friends are also friends with each other, meaning that there are redundancies in my friendship connections. Average path length is defined as the average number of steps along the shortest path for all possible pairs of network nodes. It is a measure of efficiency of information or transportation flow in a social network. One of the most refined small world models was formulated in recent work by Watts and Strogatz. They demonstrate how to generate networks with small world properties by rewiring network ties. By increasing the number of random ties in a regular network, we get a range of networks that are with the small world properties. Their framework provided compelling evidence that the small world phenomenon is pervasive in a range of networks arising in nature and technology, and a fundamental ingredient in the evolution of the World Wide Web. The world is small because we're closely interacting with our local friends, and we're also not too far away from people who are outside of our perceived immediate circles. Because of random encounters in life, the world people are connected together in a large web. If you're going to replicate Milgram's experiment, or using other methods like email or social media to spread the postcard, what degree of separation will you find? Looking at this global Facebook network, what is the degree of separation? Do you think it will still be 6?